Hello students, this is Dr. C. Sonia, Assistant Professor, Department of Chemistry, SNS College of Technology. So in the last video, we were seeing about the water quality parameters and we were seeing about the physical parameters. Now we are going to see in this video about the chemical and the biological parameters. Okay, so chemical parameters, the first is the pH. pH of water is nothing but negative logarithm of H plus ion. So pH scale will range from 0 to 7, then to 40. So drinking water will have a certain pH, that is from 6.5 to 8. For irrigation purpose, 6 to 9 pH is desirable. Rainwater is having sulfur dioxide and nitric oxide, so it is acidic in nature. Next is the acidity. Measure of base neutralizing ability. It's called the acidity of water. Carbon dioxide and mineral acids is responsible for the acidity mostly. Sources: mineral acids, iron pyrite, sulfur compounds. So sulfur plus oxygen plus water gives sulfuric acid. Then FeS2 plus oxygen plus water gives ferrous sulfate plus sulfuric acid. So carbon dioxide, it is obtained from the smoke of the vehicles and industries. The significance of acidity: mineral acids are dangerous, undesirable for the use. Next is the alkalinity, measure of acid neutralizing capacity. It is imparted by OH minus ion, CO3 2 minus, carbonate and bicarbonate ions. Sources: its sources are industries like fertilizer, detergents, paints, etc. Significance: its high alkalinity is dangerous to health of aqueous organisms. In boilers, it causes caustic embrittlement. So the water that is present in the boiler is always treated before it is being used. And removal of this alkalinity is by adding dilute hydrochloric acid. And the next parameter is the nitrogen. Nitrogen is an inert gas, so it's not that important. So sources are plant materials and fertilizer. It's removed by boiling water. And the significance: it has no corrosive effect and no much significant. So we need not worry if nitrogen is present in the water. And next is the fluoride. Fluoride, by this dissolution of geological compounds it occurs. Little concentration is possible in surface water. Sources: cryolite, fluorapatite, some rocks having fluoride. So what is the significance? If the fluoride content is between 0.7 to 1.2 milligram per liter, the it is significant or it is good. If the low fluoride causes caries in children and high fluoride causes fluorosis. So you should maintain the fluoride from 0.7 to 1.2 mg per liter. So you can see, to protect the teeth from decays and the toothpaste, they will add fluoride. But also in addition to that, if you use the fluoride that is more in the water that we are utilizing, it will cause fluorosis. Removal: precipitate using aluminum salts in basic medium, by using strong anion exchange resin, and by adsorption on Then chlorides. 250 mg per liter is the limit in the drinking water. 200 ppm. Chlorine must be 0. Chlorine gas must be 0. Then sulfates, 250 mg per liter limit. High levels, it causes cathartic effect. Nitrates, 45 mg per liter is the limit in water. Then arsenic, it should be less than 0.05 mg per liter. If it is higher in the value, it will cause arsenic poisoning. Next is the biological impurities. Microorganisms are the main causes of the biological impurities. Significance: it causes disease, pipe carrying capacity decreases, falling in membrane filtration. Then control. The microorganisms are controlled by chlorination method, sterilization, using copper sulfate and also ultraviolet radiation. So there are certain parameter and WHO recommended values of ppm, how much it should be present in the water, and ISI ppm as well. So first is the color, odor and the taste. Colorless, odorless and tasteless. ISI recommended is also colorless, odorless and tasteless. So if the water is colorless, odorless and tasteless, it is very safe. pH. pH is from 6.5 to 8. WHO recommended. ISI is also 6.5 to 8. Total dissolved salts, WHO recommended 500 ppm. ISI is not recommended. Dissolved oxygen, ISI 3 ppm. Chlorine, WHO 250, ISI 600 ppm. Sulfate SO4, WHO 400, ISI 1000. Nitrate, WHO 45 to 50, ISI 45. Cyanide, WHO 0.2, ISI 0.01. Fluorine, WHO 1.5, ISI 3. CrPbAs, chromium, lead and arsenic, Hu 0.05, ISI 0.05, 0.1. Characteristics or testing. So we can do the testing of water to find its characteristics. First is two important tests. First one is the dissolved oxygen, DO. It is the amount of oxygen dissolved in the given amount of water at constant temperature and pressure. Significance. It's very important for aqueous organisms. Dissolved oxygen measures control of river or water pollution. Dissolved oxygen must be minimum of 4 mg per liter. Next is the biological oxygen demand. The amount of oxygen required for the biological decomposition of the organic matter in a given sample of water at 20 degrees centigrade over a period of 5 days, it is expressed as BOD. Significance. It measures the amount of organics and pollutants. Next is the chemical oxygen demand. This is also an important term. So the amount of oxygen required for the chemical oxidation of the organic matter using some oxidizing agents like potassium dichromate or potassium permanganate, and the significance, it can give you the measure of pollution. Thank you.